Hi, welcome to my video on the length of a segment, second video in the unit on coordinate geometry. The length of a segment is found by using a distance formula. So let's derive the distance formula. We have 2 points. This is the first one, x1, y1. This is the second one, x2, y2. So if I drop a perpendicular line down to this point, and I draw a horizontal line to this point, they both intersect at a right angle right here, and that means that this point will have the coordinates of, on a vertical line, all the x's are the same, so this one will be x2, and on a horizontal line, all the y coordinates are the same, so this one is y1. That means that the difference here is between y2, so that difference right there is y2 minus y1. And this difference right here is between the x's, which is x2 minus x1. So notice we're subtracting the x's, x2 minus x1, and we're subtracting the y's, y2 minus y1. So as a result, we've created a right triangle, so we have the Pythagorean property. C squared is a squared plus b squared. And we let C be the distance from one point to another, so d squared, and let the a be the x's or the y's, it makes no difference, x2 minus x1, and the b be the difference in the y's, y2 minus y1. So, and as a result, the d is plus or minus the square root. The d squared is equal to these two squared, then d is the square root, plus minus. But when we're dealing with distance, the distance is always positive, so we're dealing with the positive square root of the difference of the x's plus the differences of the y's. So there's the distance formula. D is equal to the square root of difference in the x's squared plus the difference in the y squared. So that's the distance formula. Now let's use this distance formula to find the distance between each of these pair of points. So this is x1, y1. This is x2, y2. So the distance formula, d is equal to the square root of x2 minus x1 squared and y2 minus y1 squared. So this is the first point, that's the second point. So we fill in the information. x2 is 7 minus the 7 squared. y2 is 4 minus the negative 1. And we work out the bracket first. We get a 0 squared. We work out the bracket. Double negative is a positive, so that's a 5 squared. So 0 squared is 0. 5 squared is 25. That adds up to 25. The square root of 25 is 5. And as you can see, the x coordinates are the same. So when the x coordinates are the same, you're on a vertical line. So from negative 1 up to 4. If x is negative 1 up to, if y is negative 1 right here up to 4, that's 5 units. And we have another one to do. So let's call this x1, y1, x2, y2. And again, if you keep writing down the distance formula, after a while, it's easy to do. x2 minus x1, add on y2 minus y1, and we sub in the values. x2 is negative 3, subtract negative 8, y2 is 7, Subtract y1 is 5. So that makes it. Simplify it, double negative is positive, so that makes it 5 squared. And that's a 2 squared. So 5 squared is 25 plus 4. That's the square root of 29. And the square root of 29 can't be simplified because it's a prime number. And we have another one to do, but it says find the distance between these two as a radical in the simplest form. So x1, y1, x2, y2. So d is equal to, and again, formula is x2 minus x1 squared, add on y2 minus y1 squared, and fill in the numbers. X2 is a 1 minus negative 1. Y2 is 6 minus 2. And a double negative is a positive, so that's 1 plus 1 is 2 squared, plus 6 subtract 2 is 4. Notice I worked out the brackets first by PEMDAS. Now I have the square after. You always work the inside of the brackets first. 4, 16 gives 20, and 20 perfect square is 4 times 5 is, and that leads, square root of 4 is 2, so it's 2 root 5 as a radical in the simplest form. Now let's do another one. And we have a, so a is x is 1, y is 3, and b is x is negative 2, y is negative 1. So this is x1, y1, x2, y2, and the distance formula, square root of differences in the x's and the differences in the y's. Very similar to slope. And we fill in the ordered pair. x2 is negative 2, subtract 1. y2 is negative 1, subtract 3. Simplify the brackets first. That's negative 2, negative 1 is negative 3. Add on. Negative 1, negative 3 is negative 4. And we square them. 9. Negative 4 squared is 16. 25 gives me a 5. So that's how we work with the distance formula. The distance formula is just the Pythagorean property with the differences in the x and the difference in the y's being squared. And practice means, in terms of my video, is practice is pause the video and see if you can work these out. So here we go with number 1. So find the length of RT, and this is x1, y1, x2, y2. So the distance formula is square root of x2 minus x1 squared, y2 minus y1 squared. And here we go. x2 is negative 9. Subtract. x1 is negative 3. y2 is 10. Subtract. y1 is 2 squared. And we simplify the brackets first. Double negative is a positive, so that's negative 6 being squared. 10 minus 2 is 8 being squared. Negative 6 squared, negative 6 times negative 6, 36. 8 squared is 64. Adds up to 100, and the square root of 100 is 10. So the distance between these two ordered pairs is 10 units. Number 2, don't forget, if you wish to pause the video. Find the distance between 0, 2, to the midpoint of the segment joining 1, 4, and 5, 8. So let's do the midpoint. And the midpoint is x1, y1, x2, y2. So the midpoint formula is average, so it's x1 plus x2 over 2, y1 plus y2 over 2. And so we have x1 is 1 plus 5 over 2, y1 is 4, y2 is 8 over 2, that's 6 over 2, 12 over 2, and that's a 3, comma 4. Now it says wants the distance from 0, 2 to the midpoint. So what we're now doing, we're looking at 0, 2, and we're also looking at the midpoint. So I found the midpoint. Now I'm going to use these 2 points to find the distance. So this is x1, y1. This is x2, y2. And the distance formula is square root of x2 minus x1 squared, y2 minus y1 squared. And we fill in x2 is 3, x1 is 0, y2 is 4, y1 is 2, and that gives us 3 squared plus 2 squared. That's 9 plus 4 gives us a square root of 13. So notice I had to find the midpoint, which I did, and then find the distance between 0, 2 and the midpoint. Number 3, triangle ABC has the vertices of A, -1, -2, B is 4, 3, C is 5, 16. Find as the radical, in simplest form, the length of the median from B. The length of the median from B. Just draw a little quick diagram here, and just an approximation of what's happening. Okay, we have A is, make that, A is -1, -2, so pretend is right there. B is 4, and we go 3, so let's pretend is there. And C is 5, 16. So again, I get way off the chart, so let's pretend 5, 16 is way up here. And here's the triangle. But it says it wants to find the length of the median from B. So there's B, the median leaves and goes to the midpoint. So there's the midpoint. So the median goes from B to the midpoint of AC. So I have to work out the midpoint of AC. So the midpoint of AC. So A is -1, -2, and C is 5, 16. So the midpoint is, this is x1, y1, x2, y2. So the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So that's -1, add on 5, x1, x2 over 2. y1 is a -2, add on 16 over 2. So that gives 4 over 2, 14 over 2. So that's 2, 7. So that's the midpoint of AC. And we want the length of that median. So we're going to use the point from B. So B is 4, 3. And the midpoint is 2, 7. So I'm going to find the distance from the midpoint to B right there. That distance from there to there. And so there's B, there's the midpoint. So this is x1, y1, x2, y2, and the distance is the square root of x2 minus x1 squared minus y2 minus y1 squared, and x2 is a 2 minus x1 is a 4, and y2 is a 7 minus a 3. Work out the brackets first, so it's a negative 2 squared, and that's a 4 being squared. Negative 2 squared is 4, 4 squared is 16, that gives you the square root of 20, and 20 is a 4 times 5, square root of 4 is 2, so it's 2 root 5 as a radical in simplest form. So hopefully you're understanding the distance formula. The midpoint formula is used, but the distance formula is the Pythagorean with the difference in the x squared, difference in the y squared. Okay, 2 more to do. As practice, pause the video and see if you can work this out. We have the vertices of a triangle DEF. There's the vertices. Find the length of the segment joining the midpoints of DE and EF. So again, just a little quick diagram here. Oh, I gotta keep this straight. So we have a negative, x is negative 1, y is 0, so there's D. E is x is 3 and 6, so let's pretend that's E right there. And this one is a 9 and a 24. Again, we're gone way off the chart. I don't know why I put these so far apart. I could have kept it down here somewhere and made it easy. So let's make it, well, 9. That's 3, 9, and a 24 is way up here. So let's join these up. 9, 24. Okay, so there's F up right there. So they want find the length joining the midpoints of DE. There's the midpoint of DE. And this is the midpoint of EF, which is right here. So let's call this midpoint M, and let's call this midpoint N. And now we want to find the length of the segment joining those two midpoints. So we're trying to find the length of this segment right here, MN. So let's find the midpoint of DE, and so the midpoint is the sum x1 plus x2 over 2, y1 plus y2 over 2, and we're looking at D and E. So D is 1, 0, E is 3, 6. So here we go. X1, negative 1 plus 3 over 2. And y1 is 0 plus 6 over 2. So that's negative 2 over 2. And 6 over 2. So that's a 1 and a 3. So let's call that M. Now, let's find the midpoint of, we got to find the midpoint of EF. So let's work out the midpoint of EF. And E is 3, 6, and F is 9, 24. So it's the midpoint we're doing, so it's x1 plus x2 over 2, y1 plus y2 over 2. And here are the 2 points, x1, x2. So it's 3 plus 9 over 2. y1, y2, 6 plus 24 over 2. And that's 12 over 2, 30 over 2. So that's a 6 and a 15. And let's call that n. So now they want the length of the segment joining these 2 midpoints. So we're getting the length, or the length of mn. So m is 1, 3, and n is 6, 15. So we get this is x1, y1, x2, y2. So the distance is x2 minus x1 squared, add on y2 minus y1 squared. And we're using these points. x2 is 6 minus x1 is 1 squared. y2 is 5 minus, oh, not 5, that's a 15, gotta be careful. 15 minus 3 squared. And that gives us 5 squared. 15 minus 3 is 12 squared. 5 squared is 25. 12 squared is 144. Adds up to the square root of 169. And the square root of 169 is 13. So I found the 2 midpoints. I used those 2 midpoints to get the length, the distance formula, the distance formula. So notice I'm used to writing it down, putting x1, y1, x2, y2, so I don't get confused. Midpoint, you just got to add up the x's and add up the y's, not too confusing. Be careful with distance. And number 5, again, if you wish to pause the video, do so. Find a radius of the circle whose diameter has these endpoints. So there's 2 ways to do this. One way is to find, you got the endpoints of the diameter. So one way is to get the middle of the diameter. So the midpoint of the diameter is center of the circle. So let's get the midpoint of, we got 1, -4, and we got 7, 4. So the midpoint of that diameter, midpoint is x1 plus x2 over 2, and y1 plus y2 over 2. So we got a 1 plus 7 over 2, -4 plus 4 over 2, 8 over 2, and 0 over 2 is 0. 8 divided by 2 is 4, so notice I just left that a step because it's quick to do. So we have the midpoint, so we have the center of the circle. So the radius is the distance from the center to a point on the circle. So if I take the center, which is 4, 0, I can take either point. So I can go use this point or this point. So let's use the point 7, 4. Makes no difference which one you pick. So we're going to find the radius. So let's call it radius is the distance. The radius is the square root of x2 minus x1 squared, y2 minus y1 being squared. And so we have x2 is a 7 minus a 4. And we have a 4 minus 0 squared. That's 3 squared plus 4 being squared. So that's the square root of 9 plus, so I'm going to say 9, I'm going to write down. I'm going to write down a 4 again. I forgot the square. 4 squared is 16. 25 square root of 25 is 5. So just a little quick picture to show you. We have a point. X is 1, y is negative 4. Let's pretend there. And we have a point which x is 7 and y is 4. X is 7. Y is 4. Let's pretend is there. So this is the x is 1, y is negative 4. And this is 7, 4. So we have a circle that goes like this. And this is the diameter. So the midpoint is right there. The midpoint is 4, 0. Halfway between 7 and 1 is, that adds up to be 8, so it's a 4. Halfway between 4 and a negative 4 is 0. So there's the center. So the radius is from here to here. Or you could have used this one, from here to here. Radii are equal, so, but the radius is 5 units long. So that's a review or going over the distance formula. And notice I integrated the midpoint formula in that because it will come up again and again and again. So if you liked the video on the distance formula, click on the like button, subscribe. If this is your first time, visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content of my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.